This is Mathematics MA110 Set Theory Lesson 2. Okay, so it's a continuation of set theory, and in this video actually talk about the laws of algebra of sets. So these are the laws that we'll be using to simplify some sets. Okay, then let's get started. And the first one which we'll talk about is the so we have what we call the idempotent laws. Idempotent laws. So for the idempotent laws, you must know that A union A is simply equal to A itself. Then the other one is A intersect A is equal to A itself. So if you have a set A, then union of a set itself, it's that set itself. A intersect of a set itself is that set itself. Okay, then from there we can proceed to the associative laws. Associative laws. So for the associative laws, the first one, if you have A union B union C, this is actually equal to A union B union C. Same applies. Let's say we want to add 2 plus 3 plus 5. So we can first add 3 plus 5, then the result we add it to 2. Or if we want, we can first add 2 and 3. Then we add the final answer to 5. We still get one and the same. So you say 2 plus. There we're getting, that's 8. This is 10. Then this side, if we add 2 and 5, that's, 2 and 3, that's 5 plus 5. We are still getting 10. So same applies here. A union B union C. Union. You can first find B union C. Then the result, we find the union of what A and the result. Still getting the same answer as starting with A union B. Then we find the union of the result and C. So these are called associative laws. Then under associative laws, we also have B, where we can use intersections. A intersect B intersect C. This is actually equal to, so apart from starting by finding B intersect C, you can first find A intersect B. So you can first find A intersect B, then intersect C. It's one and the same. So these are called associative laws. Then 3, we have the commutative laws. The commutative laws. Commutative laws. So for the commutative laws, if you have A union B, actually this is just the same as what? B union A. Then B, if you have A intersect B, this is simply B intersect A. Remember, if we talk about addition and multiplication of numbers is commutative, what does that mean? It means that 2 plus 3 is the same as what? 3 plus 2, we can start with that. Then 2 times 3 is the same as what? 3 times 2. We still get the same answer. So these are commutative laws for what? For sets. Okay. So rather than the commutative laws, we have some other laws. So let me just do that. So from the commutative laws, number 4, we have what we call the distributive laws. So the distributive laws. Distributive laws. So for the distributive laws, the first one, if you have A union B intersect C, this is the same as one. So we can distribute this one. An example which I can give, let's say we have 2 there, then there is the multiplication, let's say A plus C, like that. So what you do, you can distribute that to A and C by simply multiplying. So this is actually the same as what? 2A plus 2C. The same thing can be applied to sets. So here, what you do, as you can see, this plus is in between there. So you expect intersection to be in between when you distribute A, U, A, U. So here, we have A union B. A union has been distributed to B. Then in between, there should be intersection. So A union B, then in between intersection. Then A union should also distributed to C. Should have A union C, like that. Then here what you do, you enclose what you have this side in parentheses, like that. So this is A union B intersect A union C. We have simply distributed the same way we did for this one. Then you can factorize back if you want. If we have, let's get the same A union B intersect A union C. Okay, let's start with this one. The algebraic expression there. We can factorize 2. We can say 2, then A plus C. So in between there, there's multiplication. The same thing can apply here. We can get back to that. So we check A union common there. We simply say A union. Then what is remaining? B intersect C. So say B intersect C. So these are called distributive laws. So that's the first one. Then B, for B we can intersect and union, where we say A, where we have union there, we have intersection, then B union C. So this will be equal to, so let's distribute A intersection. So if you distribute A intersection multiplied by B, we have A intersect B there. Then union should be just in between union. Then A intersect multiplied by C, you say A intersect C. Then you enclose A intersect C and A intersect B in parentheses. Don't forget A intersect B intersect C. Then you can get back, just factor out A intersection, you remain with B union C. You would have gotten back to what you had initially. So these are what we call the distributive laws of sets. Hope that's clear. Number 5, we have what we call the identity laws. The identity laws. Okay, so for the identity laws, the first one we should know that A union of empty set. So any set union of empty set is the set itself. Otherwise, if you have set A equals to what? A, B, C. And also another empty set there. Another empty set, let's say set C, which is an empty set. What is the union of these sets? A union empty set. You simply get the set A itself. So A union of empty set is the set A itself. Then for B, what if we have A intersect of empty set? Let's find A intersect of empty set. So what's the intersection of A and C there? A has A, B, C there, and C has nothing. So their intersection is what? Is nothing. So we can say their intersection is what? An empty set. So any set intersection with empty set, it's an empty set. Then for C, what if we have A union of the universal set? A union of the universal set. Let's say the universal set E contains all real numbers. That's the universal set. Then we have set A, which contains the numbers, let's say prime numbers. Set A, all real numbers. Set E, all real numbers, which is the universal set. Set A contains the prime numbers. Now, what's the union of set A, prime numbers, and E, all real numbers? So you find that all prime numbers are simply under real numbers. So the union of any set and the universal set gives the universal set. The union of any set and the universal set gives the universal set. Then what about the intersection of any set and the universal set? So the intersection of what? All real numbers and prime numbers, you find it's prime numbers. So intersection of any set and the universal set, it is that set itself. Giving a practical example, let's say set A simply contains, so this is another example, forgotten about this, okay? So set A, let's say it contains 1, 2, and 3, that is set A. Then the universal set contains 1, 2, 3, 4, 5, 6. So what's A union E? If we have to find the intersection of A and universal, we find that, rather if we were to put A and the universal together, you find that you get the universal. Since we can't repeat the elements, they have to be distinct. Then A intersect E. The intersection of A and E, you find that it is A, 1, 2, 3. That's it. So, okay, so these are called identity laws. Then from identity laws, we can talk about something else. Okay, we proceed to what we are calling complement laws. So the complement laws, so we are calling these the complement laws. Okay, so for the complement laws, the first one, what if we have A union A complement? This will be equal to what? This will be simply the universal set. Let's try to demonstrate. Let's demonstrate. So if we have two sets there, A and B, then the universal, then in A, let's say we just have the elements A there, B, then the intersection is C, then we have D, E, then outside we have F. So what is set A? Let's list set A there. Set A will be equals to what? Simply A, B, C. So set A is simply A, B, C. That's set A. Then what is A complement? So A complement will be equals to, so A complement means all other elements not found in set A. So we exclude set A to find A complement. So to get rid of set A, we'll remain with D, E, F. So we'll remain with D, E, F. That's A complement. Now what's the union of these two sets? A union A complement will be equals to what? So let's put everything together. It will be A, B, C, A, B, C, D, E, F. D, E, F. That's A union B. A union A complement. A, B, C, D, E, F. Now let's compare. What do we have in the universal set? A. In the universal set, we have A, B, C, D, E, F. Everything is A, B, C, D, E, F. So as you can see, we have just proved using an example that A union A is simply, A union A complement is simply the universal set. So you can have any set. B union B complement gives the universal set. C union C complement gives the universal set. So that's the first law under complementing laws. Then the second one is, what if we have A intersect A complement equals to, so let's use the same example. We have A and that A. Now what's the intersection of these sets? In this set we have A, B, C. In this set we have D, E, F. So there is nothing common. So any set intersection of its complement always gives an empty set. Any set intersection of its complement always gives an empty set. Any set intersection of its complement gives an empty set. Okay. Then what about A complement? The complement of a complement. So the complement of a complement gets us back to the original set itself. So we have initially, this is our original set, set A containing A, B, C. Then our A complement is what? D, E, F. This is our A complement. So our A complement is D, E, F. Now what if we want to find the complement of this A complement? So we want the elements which are outside A complement. So if we exclude D, E, F, what are we remaining with? A, B, C. As you can see, we are getting back to set A. So complement of a complement gets back to the original set itself. So we'll prove this law. We'll talk about proving this law. Then D, what if we have the universal set complement? So the universal set complement, this simply means we are getting rid of everything in the universal set. What are we going to remain with? Automatically we remain with an empty set. This entire universal set, to get rid of it, we remain with an empty set. So universal set complement simply gives an empty set. Then what about empty set complement? So empty set complement gets us back to the universal set. Empty set complement gets us back to the universal set. Okay. Then number 7, we have what we call De Morgan's laws. So for De Morgan's laws, let's say we have A union B complement. This is equal to, so when the complement is distributed to A and B, the sign changes. The what we have there changes in between. So we have A complement, then union will change to intersection B complement. So you should master this. This is called De Morgan's laws. Then the second one, if you have A intersection B complement, distributing that complement, you end up having A. So you end up having A complement, the intersection will change to union B complement. These are called De Morgan's laws. Okay, so these are the common set laws you should master. So make sure you master these common set laws before we start solving the questions. So just make sure you go through, you study them, you master them, so that when solving questions it will become very easy. So the next video we'll first prove the what? These De Morgan's laws, we have to prove them. When you prove the De Morgan's laws, we'll see any other laws we are supposed to prove and solve more questions. For now, make sure you master these set laws. Make sure you practice, master them. Okay, so that's it for this video. See you in the next video.